All right, welcome to the V3 system breakdown, I suppose. This has taken me many months to get made, so I'm pretty excited about it. All of the V3 casings have the same sort of design methods to them. So what I'm going to do is start by comparing a V2 casing to a V3. That'll break down all of the new design changes and improvements that have happened, and then we'll get into the casing individually and what each one achieves. So this is a V2 XR battery casing, and then this is a V3 GT battery casing. Different board casings, but they each will show off the design improvements. So the first and biggest improvement that I made to the casing systems is that of the way that the gasket works. With this V2 casing here, the gasket is installed into a channel around the edge of the 3D printed casing, and instead on V3, the casing is installed around the edge of the machined lid. The reason for that is because with the 3D printed casing, you can only achieve so much accuracy and resolution in the model due to the fact that the nozzle has a certain width, 0.6 millimeters in this case. It's laying down plastic layers in a way such that you need quite a thick wall area to fit your gasket into the print model. What that ends up doing is reducing the internal area and volume that's available to fit your components, just because fitting this gasket requires extra area. But in the case of the machined lid, because it's a subtractive manufacturing method, you can have a much higher resolution of your part, and therefore you can fit a gasket around the edge of your lid, and yet at the same time end up using significantly less area around the side of your casing. What that's going to do is massively increase the internal volume without changing too much of the design, basically. So every V3 casing is essentially significantly larger than the V2 predecessor, which is excellent. The next problem that was had with V2, these casings were printed flat in this orientation, just from the ground up, out of nylon carbon fiber. That worked for as many people as possible, which is good. But there were a few cases of the casing splitting down the length of its layer lines just from the up and down impacts from drops or jumps, and that was just an issue which I wanted to try and improve upon. The way that I've done it with V3 is by printing the casing instead at 45 degrees. The main reason for those splits in the casing is because it was splitting along the layer lines of the 3D printer, and instead by printing at 45 degrees like this, you completely offset the weak point of the layer, and that's just going to increase its strength against typical one-wheel use, like slapping the tail on the floor and that kind of thing. These casings are also printed out of PPACF plastic. PPACF I've found to be significantly more improved for our use case. It's enormously more rigid, it's more chemical resistant, it's more water resistant. It's of course significantly more expensive, but that's well worth it in my opinion, because so far these have behaved significantly better than nylon, so that's fantastic. The last couple of improvements are just small details. So the bolts on V3 casings extend from as deep as possible in the casing all the way up to the lid. Around the wheel side here, the bolts are fully from the bottom of the box all the way up to the top, and what that's going to do is compress as much plastic as possible and just increase the rigidity of the structure, whereas in the V2 casing that wasn't applied to all of the boxes, whereas it is now. And then the last improvement, these LED windows had a issue of flexing from the underside before because there wasn't that much support. What most people do is add more of these LED window bars here just between the top and the bottom, just to add structural stability. What I've done instead is added these towers behind where you're going to sit your LED bar, and that presses against the top of the lid. So therefore you get improved structural strength of your LED window without blocking your light, which is excellent. But now that we've gone through each of these design changes, all of these are now applied to these new casings, and we'll just get into the new casings. So jumping into V3 GT, we have the V3 sim casing, V3 battery, and of course V3 controller as well. Only have sim and battery here at the moment. What's excellent about these design changes is that the sim casing has exactly the same internal volume as the battery casing does, unlike V2, which was slightly different. So you can fit a full 20S2P 21700 in here, and you can fit that into the tail as well. So if you did that with a Fusion core setup, you could have a 20S4P one wheel with like 1,600 watt hours of range, which would just be stupid. There's also versions of this lid to mount a VESC on the inside. I've done a build with that to do a 32S2P Superflux one wheel. Yeah, these are essentially identical in design. You still have the M6 ports here on the underside of the cable gland to add foot pad connections if you're not using a Fusion core. Still quite similar to V2, just with of course all of those upgrades. But now jumping into XR, which is something I've worked on for much longer and is absolutely ridiculous in my opinion. So we'll start with the fact that there are 3 casing sizes. GT is just the one set size, utilizing my Vow GT mushies as well, because I feel that that's just the best form factor for the GT frame, whereas the XR has now an enormous amount of different sizes to utilize different battery configurations. So the 3 sizes are slim, stock, and torque. Each one completely changes the way that the board works. So the torque size, which is this casing here, the torque size utilizes the torque bumper from the Float Life and allows you to fit full large 21700 size battery packs in a 2P config in your XR frame. So that's 18S2P in the tail, 18S2P in the front, because there's sim and battery casing versions of this. And what's excellent about this design over my V2 version is just the sheer increase in size on the inside. The internal length here is 153 millimeters of length, which is about half a centimeter longer than the internal size of my previous casings. That's going to give you massively more room to fit your pack lengthways and then also fit your BMS in the tail. The casing is also wider on the inside, and what that's going to let you do is fit 24S2P 18650 packs as well. There's a few people overseas who are making those. The only issue with my version of these torque casings, despite the fact that they have enormously more internal volume, you do need to make modification to your torque bumper. So I have a torque bumper here, and you can see that it does have a little lip here on the wheel side of the bumper. That would intrude onto the internal side of the casing here. So what you need to do is cut this lip away with a knife or any tools that you see fit. And then once you've done that, that's when your casing will fit. You can see it's not fitting quite right now. And then, yeah, you can make full use of this extra room on this side here, which is only possible with my new gasket design. So that's the torque sizing. It's available in sim and battery casings only. And then there's the stock sizing. So the stock sizing is intended for the standard bumpers for your one-wheel XR frame, so standard bang bumpers, and these are fitted to the normal sizing. So they're not suited for large 21700 cell packs, they're suited for 18650. You have a stock battery casing here. This fits a 20S2P 18650 quite well. In fact, it's got an enormous amount of room for that, so that's quite good. It's got the longest internal length of any stock casing as well. I believe it would fit the CBXR extremely easily. Although that being said, I've never seen it fit easily into anything, so I might be lying. This boasts the same LED walls in the back and a 45-degree print angle. The controller casing is a new one as well. So this controller casing is designed to be printed, again, at a 45-degree angle. It can mount the Enoid Mark 8 internally alongside any of the Thor and Jet Fleet-sized VESC controllers. It's got a very, very deep, thick handle, and an enormous amount more bolts to add to the rigidity over the V2 system. But this is of course sticking to your normal one-wheel designs with a motor plug, foot pad plug, battery input, typical LED output. It's very suited to your normal use. And then, however, this is the casing I'm excited about the most. This is the stock SIM casing. So instead of having a torque-sized SIM casing at the front, this is intended for a more standard-sized board. What you can do with this casing, making use of this lid, is mount a Jetfleet F6, Enoid Mark 8, Thor 400 type VESC. It'll sit here on this side of the casing, and then you have these extended channels around it to fit a 2P 18650 pack. You can fit up to a 12S 2P system in the front, matched with a 20S 2P in the back is going to get you an excellent board design. And thanks to my gasket design and the ability to fit so much extra stuff, I've managed to fit all of that alongside keeping the handle of your one wheel as well, which is nuts. So you could build a 135 volt, 650 watt hour board with the standard handles as well, and it'll still fit an MTE hub, which is ridiculous. There's of course still room for a slim push button on the side and a GX16 charge plug. So that's the entire stock casing setup, all using the same design features I just yapped about. And then the last one is a new endeavor. This is the XR Slim system. So this is designed to take the interesting development of the GT system, where you have a foot pad which dips below the rail line, and instead apply that to the one wheel XR frame. But of course I've done that with the intention of applying it to builds using a thin 1P 21700 pack. So I've only got one casing here to demo this, but it's available in battery, SIM, and controller types as well. And it requires the use of a custom slim Mushies foot pad, which sits on top like so, still manages to bolt to your board's rails, but cuts down the thickness of your one wheel XR by about 0.5 centimeter, and the concave of which dips underneath the rail line. If you've rode a vow GT and been able to tell the difference between a stock GT and a vow GT just because of the thinner depth of its foot pad, imagine that same difference instead applied to an XR frame, and that's exactly what this is intended to achieve. So the controller type for the Slim system has a typical motor plug, switchcraft plug input, and a battery input from the side as well. That's more so intended for people who might want to use a typical sized battery casing on the tail, but have an extremely thin front end for their one wheel XR. And then the battery and SIM casings of this variant are more intended for people who want to use a fusion core alongside this design, because these casings can only fit 18S1P with 21700 cells, or 16S1P with a BMS sat along the side here. So these aren't quite useful for people who are trying to fit a big battery. It could fit a 32S1P at most using a fusion core, or you can just have the controller at the front with a larger casing at the tail, which would be excellent for doing things like nudges or trail riding and having a high angle of attack at the front. So yeah, pretty exciting. So yeah, these casings are available up on the vow site at the moment. There are PCTG or PPACF options for printing. I'm still working on getting the PPACF 100% dialed. It is a very difficult plastic to work with, and it is very expensive, but so far it has completely blown nylon carbon fiber out of the water, so I'm very, very excited about it. This whole system has realistically been the reason for a large amount of delays with my batches. If you ordered in December, you're going to be receiving a casing that is printed out of PPACF at least, and that's a significant upgrade. And yeah, the V3 casing sets are all fully available on the vow.systems site as well. And as soon as I've edited this video and uploaded it, I will be releasing the files for all of these systems on the Vow Discord, as well as Elevons too. So, huge file release, and that's it. Yeah. Again, thanks for watching.